green. Okay, so we're going to learn about permutations and combinations. So no writing for a second. This is just what it all is about. So I have 4 markers here, all different, right? And I need to take a combination of 2 markers. So I need to pick. I need to choose 2 markers. Tell me a way I can do that. Anybody want to give me an example? I need to choose 2 markers. Give me an example of what I could do. I just want to choose 2 markers. What could I do? Well, which ones? Tell me what to do.
Just pick the last one. First and last.
First and last. So I could choose green, pink. That's a combination. Green, pink. Can anybody give me a different way I could pick? Well, I picked green, pink. Okay, I can't do that again. Give me another thing. Green, yellow. That's a different. Okay. Anything else? Is there more of these?
Yeah.
What else?
Orange, yellow.
Orange and yellow is different. I can choose these 2. Okay, so here's what we're going to do. We're going to grab our calculator. We're going to learn a new button on our calculator. Okay, so on my calculator, it's this NCR, and mine is right above my 5. So this is what I'm going to do, and then I'll have to come around to see who has different types of calculators. So I'm going to go, there's 4 objects, so I'm going to hit 4 first. I had 4 markers, and then I'm going to hit that button. So I had to do a second shift, and I have to choose 2 markers. So 4, choose 2. Were 6 ways I could have done that. So can you think of the 6 ways? I could go orange, yellow. I could have done orange and green together. I could have done orange and pink. I could have done green and yellow. I could have done green and pink, right? There's 6 different partners I can do. So I'm going to come around for those buttons. Okay, so some of you had that other type. So on that type, you do 4, then you hit your probability button. And then your probability will always give you the options. We are going to do all of these in there, but for this one, you would go to the right, enter, and then hit 2, and then enter again. So not as user-friendly, but you can get there. Okay. Okay, now, permutation is another word we're going to learn. So I am going to have these 4 markers again, and I have to permutate 2 of them. So a permutate means that the order matters. So for instance, pretend you're in a baseball game and you're the coach and you're making the batting lineup. Does the order matter? Yes. Okay. I could have the same 9 people, but I could make a bunch of different batting lineups, right? Because I can move them around. Okay. So a permutation is I want 2 markers, but I care which one I put in my right hand and my left hand. So I could go pink right, green left. Or, guess what else? I could also switch that around. I could go with my green in my right, pink in my left. I could do another thing. I could go orange right, green left. Or I could do green right, orange left. This is hard to think of. Yellow right, I could do pink left, or I could move them around, right? There's a bunch of different arrangements. So now I'm going to do this button, the permutation button, so NPR. So there was 4 markers, and I permutated with 2 of them. Is there going to be more or less ways you can do this? More. 12.
Always double.
This case, because there was 2 markers. Yes. Because for every combination, I could have flip-flopped them. So that times is about 2 on that one, yeah. Okay. So that's the understanding of what this is all about. Okay, combination. So does the order matter? When I combinated my markers, the first example, did it matter the order I put them in? No. If you do a permutation, does the order of your objects matter? Yes. So an example, it would be for a combination, I just need a committee of 2 people or something like that. How do you spell that? Is it? I'm not sure. A committee of people. So if I need to make a student council, I need 4 of you to be in my student council. Does it matter the order I'm picking you in or just who I'm picking? A permutation could be a batting lineup. Does that matter in arranging the people? Could you make different batting lineups by moving them around? Yeah. Could I make different committees by changing them around? No. Okay, there are formulas for these. We're going to write them down, and we're not even going to talk about them because you have no idea what this means yet. But they're on your formula sheet, so this is the only section of your formula sheet that's going to apply to this unit.
It's easy. Exclamation point.
So those are the formulas. They are from your formula sheet. And you're literally just copying them down because you have no idea what that means.
We're going to have to do that, or we're going to use a calculator?
You're going to have to also do that. I will. Next. That's my next step. Okay. So now, something new. There's an exclamation mark in math. What's that all about? So it's not even an exclamation mark. It's called a factorial. That's the next word we see down here. Factorial. So for what you just said, exclamation mark, is really 4 factorial. That's how I say it in math. So what does 4 factorial mean? It means 4 times 3 times 2 times 1. That's what it means. So that's what a factorial does. So 7 factorial would be what? 7 times 6 times 5, 4, 3, 2, 1. Timesing them. Okay, we can do this one in our head, and then I'm going to show you that there's a cheat, a shortcut, right? 4 times 3 is 12 times 2 is 24. You should never have to do that. Like I would never go like this, 7 times 6 times 5 times 4 times 3 times 2 times 1. I would not type that out, even though I know the answer. What is the shortcut? Everybody has this button called n factorial. So 4 factorial. That's what I'm hitting. I'm pushing 4 and then the button. So the people who had that probability button, you're still going to that. So okay, or an X. Somebody who might have an X instead of an N.
Oh, I see it.
Everybody find that button. So we already knew 4 factorial was 24. Can you do the 7 factorial? So that was a lot faster than me typing 7 times 6 times 5 times 4 times 2 times 2 times 4. Okay, and then when we looked at this formula, n was the total number of the objects. So on our example, it was 4 because I had 4 markers to start with, right? And the R is the number that you're working with, like selecting, number in your selection. What if I ever did this? (5p8). It doesn't work. Even if I wanted to type it in, 5p8, error.
Combinations of 8 when you only have 5.
Right. You can't be trying to get 8 objects when there was only 5 total. So this number cannot exceed that number, right? However you want to write that. In other words, R has to be less than or equal to N. If you like your math terms, but just that understanding, you can't ever have more. You can't pick more than you have, right? Isn't there a saying, don't bite off more than you can chew kind of a thing? So here's me kind of mapping something out. So when you went to the library, there was 5 books and you could pick 2 of them to take home. So you can see all the combinations of books. I could have picked the first and second book. I could have picked the first and third. There ended up being 10. And this is that when I wanted to scan 2 books out, I wanted to know how many different ways I could scan them through the buzzer. You know, at the library, you can go ding, ding. I wanted to know how many different ways I could scan 2 books. So that's a permutation because the order of my scanning mattered, and that ended up being 20. Okay, so let's try using the formula. 5c2. So this is 5 factorial. Are you looking ahead to your formula here on the top that we wrote down? 5 factorial. This needs to be r factorial, so 2 factorial. And then brackets 5 minus 2 factorial. Okay, so 5 subtract 2 is 3. Okay, no calculator typing. We're going to do this all by hand. Expand 5 factorial for me. So what would it look like? 5, 4, 3, 2, 1. What does 2 factorial look like? 2 times 1. What does 3 factorial look like? 3, 2, 1. What do you think? Is there something we can just simplify? That all cancels. And this is 20 divided by 2. So does it work? 5 choose 2? 10. So that's how the formula works. Okay, let's try the permutation formula. So that is just 5 factorial. I'm looking at the formula that we gave. 5 factorial, 5 minus 2 factorial. So fill in the formula. And then I'm going to expand. and then cancel, and that one would come out to 20, and then I'm checking on my calculator, 5p2, and it shows us that we should get 20. Oh, okay. Where do I want to start today? Okay, I'm gonna flip a few pages here. We're gonna do this lesson, so it's kind of gonna be, we'll skip the first few pages of our workbook.
It's that kind of day.
It's that kind of day. Pick and choose what I want to do. Okay, 20C4. I need you to give me the formula. So that would be 20 factorial divided by 4 factorial. Everybody's looking at their formula. 20 factorial over 4 factorial. Are you okay if I write 16 factorial? So that's that. Then it's divided by 17 and 19.
Wait, why'd you put 16?
Because the formula is n minus r, so that would be 20 subtract 4, so that I just did the 16 already. Do you see it in the formula sheet? That's where it came from. Okay, so I'm going to go 20 factorial divided by 4 factorial, 16 factorial times that, so that I know what's all on the top, what's all on the bottom. Okay, now here's the trick to all factorials. I need you to start expanding the largest factorial that you see, which is what? 20. So 20 times 19 times 18 times 17 times 16 and beyond. Do you know why I stopped there? Because I'm looking ahead to this one, and 16, 15, 14, is all going to cancel with that 16 factorial.
Won't that 16 be gone also?
Won't that what?
The 16 would be, like the 16 from in the 20
Yeah.
would be gone?
Yes, it will be, yeah.
Okay.
So if I had really expanded this entire thing like that, the 16 and then everything beyond it, 15, 14, 13, right? Do you see? It would all cancel out with that. Now, I also have an individual 17 that would go, an individual 19. Those are different than factorials, right? And now I'm also going to go 4 times 3 times 2 times 1. So you're really trying to see what you can do everything without a calculator.
Oh, is there going to be a test where we're not allowed to have a calculator?
No.
Except for that one. Oh, yeah, I guess because we have to do this work.
Yeah, to show your work. Okay. Are you okay if I do some work here? So this 18 and that, I'm going to cross out and do what? This is 18 and this is 6. So if I cross them out, they would turn into a 3 and a 1, right? 18 divided by 6 is 3 and 1. And I'm going to now cross off a 20, and a 4. What do you want to reduce those by? 5 and 1. So now look at that. Every single thing on the bottom was crossed. And then my final answer is 5 here, and then the 3, so 15.
It's just
Okay, number 2. Which which factorial is bigger? Having n plus 3 objects or n objects? Which one is bigger? What's a bigger number? N plus 3 is bigger. So n plus 3. What's one lower than n plus 3? N plus 2. What's one lower than that? N plus 1. What's one lower than n plus 1? N factorial. Why did I know to stop there? Because it's when I get to the matching of the other one.
This is all still the top.
Yep.
Okay?
So expand, expand, expand until you hit your other factorial that you see. So that and beyond would cancel all of that and beyond. Then we have this individual canceling this individual. So I'm left with this, and the title of the question said simplify. So what do you do when you simplify something? You need to do what with this? You need to multiply it to simplify it, which would mean foiling.
first, last. And then the 2 insides. Right? When you foil.
Outside, inside, last.
N times 1, n times n, 3 times n.
This first.
First outside.
Okay.
In the bracket.
Oh, okay.
Let's do, we'll skip one, we'll do this one.
The edges of the brackets. Inside the inside of the bracket.
Oh my god.
Last is the last two things.
Okay, which one of these is larger, n minus 1 or n plus 1? N plus 1 is bigger. So leave the top. N plus 1 is where we're going to start, and we're going to go down. So what's going down from n plus 1? N,
I just did.
and then we go down from n,
N first.
n minus 1, and beyond.
Outside.
So those cancel. How do you write this fraction when something on the top cancels? 1 over. And then this, it's not quite a FOIL, but it's a distribution. Okay, we'll do one more, and then I'm going to do some in your book with you. Okay, we're going to do this one together. I need you to have that formula again. So n factorial divided by r factorial, so 2 factorial, times n minus r factorial, so that'd be n minus 2 factorial. Okay, now which factorial do I expand? What's bigger, an n or an n subtract 2? What's a bigger amount? N, so n. One lower, n minus 1. One lower, n minus 2. Does anybody know the numerical value of 2 factorial? In 2, 2 times 1 is just 2. Okay, I'm going to give you a hint. You're going to run into some fractions. How would I solve them? I just apply the simple rule of cross multiplication. This should equal that. So this makes n squared minus n squared minus n, equals the other crisscross, which is 90. 2 times 45. See what I'm doing there? 2 times 45. Did you learn anything in grade 11? What do you do? Make it equal 0. There's an n squared and an n. If you have two variables, you can't isolate them. Make it equal 0. Then you're going to factor, right? Okay, I'm not done. After I factor and solve for n, there's something else. One of these answers is not allowed.
The negative?
Can you have negative 9 objects and choose 2 of them? No, that doesn't work, right? Okay, I'm going to just give you a different example, and then you're going to answer 1. So 15 choose 1 object is the same as 15 choose 14. 20 choose 3 is the same as 20 choose 17. Can you answer question 1? What, see a pattern? What is it going on? You see a pattern?
They add to make the
These two R values add. So, can you answer question 1?
9.
Should be 9. 9 choosing 3 is the same as a 9 choose 6. Why? Because in the formula, if this is 9 and 3, then this is the 6. In the other version, if this is 9, this is 6, and this is 3. See how the formula would work out that way? The R and then the subtraction, so then it just flips in the formula. Okay, number 2. NP2. Does everybody have their formula sheet? NP2 is n factorial over n minus 2 factorial. Okay, NC3, I'm on my formula sheet, so n factorial, 3 factorial, n minus 3 factorial. No, because this is a P and this is a C formula. So it doesn't work. Like you wanted to answer 5. Okay, ready? I'm going to just work with this side. What do you want to expand, the n or the n minus 2? Which one's the bigger? N. 1 lower, n minus 1. 1 lower is n minus 2, and beyond. That's where I'm stopping, right? Okay, so I got rid of my factorials. So you really want to get rid of your factorials, and I did that. On the other side, there's an n and there's an n minus 3 factorial. So out of those 2 factorials, I'm going to expand n. 1 lower, n minus 1. n minus 2. n minus 3, and beyond. What's 3 factorial in your head? Think 3 times 2 times 1. 6. Okay, I'm now going to cross multiply, but I'm not going to do anything crazy. I'm just going to write them down. So n minus 1 times 6. You see that set? I didn't simplify anything yet. n minus 1 and then times the 6 yet. Equals n minus 1 and an n minus 2. On the other crisscross, you see my crisscross pattern? At this point, it is legit to say, I'm going to divide both sides by n. Is that okay? In math, if you do something to one side, you can do it to the other. So I'm physically going to divide both sides by n. I'm going to divide both sides by n minus 1. So n equals 8. Because I would just add 2, right? I can check it out here. 8p2 is 56. 8c3 is the other one, 56. It worked out. The solution. Okay, so your goal today is page 11.